So, just like everyone else, there are creators I regularly keep up with on social media. One of those creators is Tiberius, a creator known for his technical competence in quite a few things, with web app hacking being the most notable. Tiberius posts web AppSec interview questions from time to time to encourage people to think about things and study further if they don't know how to answer the question. One time, he posted this question, and I quote, "What is the difference between web cache deception and web cache poisoning?" I looked at this question and said, well, I don't know. And into the research rabbit hole, I fell. So, web cache deception and web cache poisoning are high level terms used to describe things I already know at a low level. Let's get into definitions and examples. Web cache deception is a term used to describe a vulnerability that exploits a misconfiguration in the way a web server interacts with a caching mechanism. It tricks the cache into incorrectly storing sensitive information that is not supposed to be stored or cached, right? This typically happens when a user requests a URL with a crafted path that leads the server to believe the response should be cached, even though it contains sensitive data. For example, a user requests example.com, my profile slash my picture.jpg, where my profile is a dynamic page, but the server mistakenly treats the URL as a static resource like an image due to the JPG extension and caches it. The primary risk with web cache deception is unauthorized disclosure of sensitive information. If other users request the same URL, they might receive the cache sensitive data that was not intended to be shared. That's web cache deception. Now, web cache poisoning involves deliberately inserting a malicious response into the web cache. The attacker manipulates a request in such a way that the server generates a harmful response, which then gets cached and served to others. How this occurs, this can be achieved by exploiting vulnerabilities in the web application, such as unvalidated headers or query parameters. The attackers craft a request that causes the server to generate a response with malicious content, like a cross-site scripting payload, which is then cached or stored. The impact can be more severe than deception, as it allows the attacker to target multiple users with malicious content. For example, the attacker could cache a script that steals cookies or redirects users to a phishing site. Every user accessing the cached response could be affected, right? If you did not understand that, it's okay. Let me highlight the key differences that may help you understand. We are going to be putting these key differences in three categories, right? First is intent and mechanisms, right? Web cache deception is more about exploiting a misconfiguration to expose sensitive data. And then web cache poisoning is an active attack where the attacker injects malicious content into the cache. Second category is impact. Web cache deception leads to information disclosure. And then web cache poisoning can lead to a range of attacks, including XSS, session hijacking, or redirecting users to malicious sites. Third category is attack complexity. Web cache deception relies on simpler tactics and primarily exploits server misconfigurations. Simple enough, right? And then web cache poisoning is often more complex, requiring knowledge of specific vulnerabilities in the application, like XSS, as mentioned prior. Both vulnerabilities underscore the importance of proper cache configuration and validation of all user inputs in web applications to prevent unauthorized cache storage or manipulation. Input validation should always be a thing, as we always note. But okay, screw the boring theoretical stuff. Let's get into some actual labs and see what this looks like in the real world. All right, people, and now we are looking at the lab so that we actually see how this may happen. This lab is the exploiting HTTP request smuggling to perform web cache deception expert level, but we will get to it. Do not worry. And you could try it out before you're watching this so that you see if you are on the right path if you don't end up solving it. But this lab involves a front end and a back end server, and the front end server doesn't support chunked encoding, which means it supports the CL which is the content length, and then the front end server is caching static resources. To solve the lab, perform a request smuggling attack such that the next user's request causes the API key to be saved in the cache. So instead of caching static resources, we want the server to cache an API key, which shouldn't happen, but we're gonna make it happen. We're hackers, right? Then retrieve the victim user's API key from the cache and submit it as the lab solution. You will need to wait for 30 seconds from accessing the lab before attempting to trick the victim into caching their API key. I'll explain this 30 seconds thing when we get there. But we have this open already and we have burp. Is it running? Let's just refresh the page so that we actually have some traffic going to burp. Go to our proxy history, and as you can see, if we send this to the repeater, this is our request for the homepage, right? Nothing's being cached. Don't think there's need for that. But we want to, first of all, can you see my finger? First of all, detect HTTP request smuggling, confirm it, and then we get into our tag. So first things first, to satisfy the HTTP request smuggling gods, we need to use HTTP version 1 link. So we're going to change that. And then we are going to want to use new lines here. Let me not do that yet. But we also need to update our content length manually so that it's just easier to work with. We're going to need a few headers, and they are not here right now. So we are going to delete everything here, change this to a post request. Now we have our content length, our content type. Let me actually not do that yet. Right. Let me change this to post request first, and then delete some of the headers that I don't need. Yeah, we don't need all of this. We do not. What we need to add is the transfer encoding header, which we know the back end is using because they said so, and we are going to set it to chunked. Now we want to see our new lines, and this is set to 0 for now. So we're going to use a timing attack. Timeout. I don't know, but when we send a request, it's supposed to time out. If the server times out, then we know we have detected HTTP request smuggling, and then we can confirm it by actually smuggling a request. So we are gonna send a chunked request. 3, please. An X is for a now value, and I think I need to follow it up with a new line so that it doesn't actually append anything. And we want our content length to be 6. So once we send this request, it should time out and detect that we do have request smuggling. We'll still have to confirm it, right? And as you can see, it's taking its time. It's gonna time out real quick. Here we go. It says communication timed out. So we have detected our HTTP request smuggling, which isn't even the best part of the lab. This is just the beginning, right? So now to confirm request smuggling, we're gonna want to remove this and then get a resource that does not exist so that we induce a 404 error. We're still using HTTP version 1.1. And do we need content length and content type? Yes, I think we do. Content length, I'll put this as 3 because we are going to put 3 bytes. We want to append everything that comes after the request here, right? So we have our 2 bytes, and then everything else is appended here. So once we send this, right, now we want the server to actually update the content length, because we know that the front end server is using the content length header, right, for validation. So once we send this, the server is going to process this, right? Cool, fair, fine. And then it's also going to forward this to the backend server, but this is incomplete because we're not following it up with a new line. So it's not actually going to process this. But when we then send a request, it is going to append everything in the, let's get this. Once we then send another request, it's going to take all of this as a new request and append it here. And then this is just going to error out, and it's going to give us a 404, right? So if we send this, we're supposed to get a 200 response, but then when we reload the page, it's going to error out because then it gets that 404, like I said. This is a bad request. Why? This is a bad request because we did not actually terminate our chunked thing. But what we want, is to add a terminating value for chunked. That's why this ended up being an invalid request, because it didn't complete. So if we send that, is that the error? There we go. Yeah, new lines help pretty much when you're doing HTTP request smuggling. So we got our HTTP 200 code response. But now if we come back to the browser and refresh the page, we're supposed to get a 404, which we induced. And this is what confirms our HTTP request smuggling, right? Second part of the lab is finished. Now what we want to do is, no, don't go there. If we refresh this and log in to our account, where are the details of this thing? That's the username and the password is Peter. If we log into our account, we can see that we have an API key that we have in this path right here, my account, and then the query parameter is ID, which is equal to Wiener, which is our username, right? If we look at this in the Burp Suite, send that to repeater, follow it. Where's my caps lock on? Follow API, right? You can see that, yeah, we have our API key. And if we look at our headers, we'll see that nothing is being cached. But if we look for a static resource, which is this, you can see that is caching this because we have the cache control. Max age is 30 seconds. For now, the age is 0 because it just cached it. So we want to send this to repeater and follow it. Probably change the name. Cache static. And then we can set this to attack, right? Just so that it's easier. So if we send this, you can see that it is caching. And it's caching for a max age of 30 seconds. If we send this again, it's been cached for 4 seconds. That's the age. Send this again. It's been cached for 8 seconds. That's the age. So once this gets to 30, it'll just restart and just recache the thing, right? It just flushes the cache and then recaches it so that latency issues, it doesn't take too long to load static resources, right? You know how a cache works. But so the attack here is we want to have the server cache this, right? This age is about at like 3 seconds right now. When it gets like 26, 27, 28, we want to send a request that we have manipulated so that the server caches the second request that we smuggle, which is then going to cache the API key of another user. If that doesn't make sense, let's actually do it so that you see it. So as you can see, to get the API key of for our user Wiener, right? Why is the name Wiener actually? It's kind of weird. So we have to know the ID, but we don't know the ID of the other user that we're trying to attack. So let's see if we can retrieve the API key without the ID. And if this works, which it did, we can just use the bare bones my account without the ID to retrieve the API key because it has a session cookie, right? So we know that we can use this path in our attack to try have the server catch that. So we are gonna delete this and use the ignore header. And do we follow this up with a new line? No, we do not. So what's gonna happen is we're gonna send this request. Server's gonna process this, cool. Then it forwards this request to the backend server. But this is incomplete because we are not following it up with a new line, right? What's gonna happen now is we are gonna be sending this static resource until about 27 seconds. At about 27 seconds, we are going to then send this request. And we know from the lab that there's a user that's continuously refreshing and whatnot. So the server is going to take that user's get request, my bad. The server is going to take that user's get request and then append it here, right? So now this is what that user's request is going to look like. We're using this ignore header so that it appends this path. I mean, it ignores this whole path and then just uses everything else. It's going to have that user's host and that user's session cookie, which means then it's going to cache the my account page for that user. And then we can then retrieve that page from the cache and look at their API key. Seems pretty difficult to understand, but trust me, it is not, right? So I think I have everything ready here. My account, ignore, cool. And then so now what we just need to do is get to like 26 or 27. Yeah, this is kind of boring. We have to keep doing it until it gets to like 26 or 27. And then we send the deception request. Okay, it's at 26 now. Let's send this a couple of times, maybe 10, 7 times. I have no idea how many times I've sent it so far. But cool. Now, this should have cached that user's request because they refreshed their page. And if we send this now, it shouldn't return this, but it should return the my account page for that other user. And as you can see, it's now different. And if we search API key, we have a new API key and the username is administrator. So in essence, we tricked the backend to cache this user's page instead of the actual static resource, because this user was refreshing their page, right? And so it was caching the static resource, but then we made the server take all of this and append it to our request. Again, it ignores this because we have the xignore header. It takes the host name and then it has the cookie. It has the session cookie for that administrator user. That's why it ended up caching the API key. And to confirm this, we can copy this and then submit it. Where's the actual submission thing? Submit solution. And hopefully we have solved the lab. Is it Burp Suite that's interfering with my business? Yeah, congratulations, you have solved the lab. So this is the web deception path. There's different ways to do this, but I just found Portswigger to be more useful. So I hope you liked this part. I hope the explanation was enough. If you have questions on this, hit me up in the description. After this, we're going to be showcasing the web cache poisoning, and then we can wrap it up. And hopefully you see the difference between this and the next lab that we're going to be doing. And we're still going to be using Portswigger because it's free and great. All right, people, last lab, which is web cache poisoning. This one is pretty neat because there's a lot of things you can do after this, but I will do a follow-up just to show those things. For now, we're just going to do what we need to do, which is trigger XXS and hit the document.cookie, right? We should poison the cache and alert document.cookie. So the lab involves a front end and a back end server, and the front end server doesn't support chunked encoding, so it's using CL. The front end server is configured to cache certain responses, and that's obviously static resources, right? To solve the lab, perform a request smuggling attack that causes the cache to be poisoned, such that the subsequent request for a JavaScript file receives a redirection to the exploit server. So we're supposed to somehow redirect the user to a domain or a server that we control, which is the exploit server, right? So I already have this open in Kali. How does this happen? Let me first try explain that. You're auditing your app, you're doing new testing, you open your developer settings for Firefox, and you look at the cookie settings, right? It has session set size, it has the HTTP flag set to true, which means that client-side scripts cannot actually access, right, our cookie. JavaScript will not be able to access our cookie. So even if we do spawn an alert document.cookie, you're not going to see the cookie because JavaScript cannot access it, right? Cool. We have same site set to none. That means that any cross-origin request is going to include the cookie. Do you understand that? If a third-party request is made, the cookie is going to be included in that request, right? And then it also has the secure flag set to true, which means that the cookie is only included in requests that use HTTPS. This means we can write a user session even in third-party domains. If we send a request to a browser or a host or a server that we actually not browser to a server that we control, the user's cookie is going to be included. And in any request that is made to this server, the user's cookie is going to be included too, which means we can write their session and trick them to perform actions on our behalf without actually needing to see their cookie, right? This is what I'm going to do in the follow-up, but for now, we're just going to demonstrate that we can trigger an alert with the document.cookie just so that we solve the lab. So we already saw in the previous section how to detect and confirm the HTTP request smuggling. So we're just gonna go through that real quick. Do we even have any history? Yes, we do. We want to send that to the repeater, which I didn't actually do. Right. Change this to a post request. Remove everything outside of the host. Update that. For now, we don't want the content length update. We want a transfer, if I can type, encoding, header set to chunked, right? We want to terminate our chunk, and then we need to set a get request for whatever path with this same HTTP 1.1. Is that what we're doing? Yeah, set that there. Okay, cool. So this is what we're going to be using for our HTTP request smuggling. I'm going to need another normal request. Let me actually just send this. And post request call content length. For this one, we can update the content length. And then it's going to be please equals subscribe, just so that we see what's happening in the back end. I'm just setting things up. Don't worry about it. You can follow, but I will explain everything once we get there. So our stuff is set up for request smuggling, which we already showed how to detect and confirm. Now what we need to do, as the challenge said, is to look for some sort of redirection, right? We want to look for functionality in the web app that returns a 302, which is where we get to redirect users. So if we browse the website, look for functionality, comments, yada, 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 all that jazz, you could post a comment. Please match the request format. What? I don't know. Website? What's the requested format? I don't know. Fine. Don't post a comment there. Dang. We can hit back just to see what that does. We can go back to the post and then we hit next post. So what we're looking for in our Burp Suite history is anything that returns a 302, which is this request right here. We shall send it to the repeater. And if you send it, it means it's returning a 302. Why is it not actually showing anything? That's weird. Yeah, there we go. Now it shows 302. And then it says the location is this, that, yada, yada, yada. Don't really care. But in our HTTP request smuggling, we are going to try, let's change the names of the stuff. Normal. And then this is redirect. Tag. Maybe go back to repeater. Yeah. So what we want to do is get this portion right here. Replace that. We need the content length and content type. We want to automatically update this so that it actually works. Do we need to set the content length? Let's see. Let's try it without. So if we send a normal request here, we're getting a 200, right? Sending a normal post request, we're getting a 200. If we send this does a redirect. So if we smuggle this thing, right? After we smuggle this request right here, once we send a normal request, this is supposed to return 302 to this post ID 7, right? Let's see if that actually works. or we might need to add a few more things to our payload. But duplicate header means not allowed. Bad requests. Something did not work. Content length 3. Let's see if it works like this. Okay, there we go. We needed to add a body so that it actually gets appended. So as you can see, it's redirecting to post ID 8. Is it not supposed to be 7? I don't know why it's going to 8, but post ID 8. It's appending a / and then everything after this. So what we can do here is see if we can redirect it to an arbitrary host. And our host is going to be please subscribe.com, right? And then smuggle this. It returned 200, cool. And then see what happens after we send this request. That did not work because that may actually exist. Does not exist. Let's see if that works. Send that, and then try see if it gets redirected. Exactly. So here we go. It got redirected to this domain, which we could then change to something we control, right? Please subscribe. Dot does not exist, and then it appends this thing. So what we were given here a exploit server, which we can use as the domain that we actually control, and then it has the path /exploit, which we want to change to /post because again it's appending / and then post, right? We might want to change this to text JavaScript. So like the challenge said, we want to do the document.cookie so that we just complete it. Then I think this should be fine. We can store this, and it is using HTTPS because the secure flag is set in the cookie. So this is now the domain that we want to add to our smuggled request. Where is it? Right. This is the domain right here. Right here, right? So once we send this, if it does get cached, whenever a user requests the cached resource, it's redirecting them to our domain and then making them execute the JavaScript that we have on the page. But now we need to find a static resource to actually cache. It's going to be the same thing we did in the last bit with the web cache deception. As you can see, max age is 30. Right now it's 1. So we're going to wait for it to get to around 27. And if I haven't already mentioned, shout out to Jarno Timmermans. I'll link his channel in the description. I followed some of his videos to get through some of the labs because I didn't actually know what I was doing. But shout out to him. Great content. You can check his channel out after this. But we're going to have to restart this and wait for it to get until like 27. And then we'll send our poisoned request and smuggle in our sneaky domain right here. Yeah. Yes. Let's do that. 17, 18, 19, 26, 27. All right, cool. Let's send this. Send it a couple of times. And then let's see if it actually worked. So now we want to send the normal request and see if we were redirected to our thing, and it wasn't because I probably sent it too many times. So let's try this again. 17, 18, 19, 20, 21, 23, 25, 29. Send that, right? And wait for at least 2 seconds maybe and see if we were redirected to our domain. There we go. We were redirected to our domain. So now if we come back to the home page and we refresh, there should be an alert maybe. I'm hoping. There's no alert. Dang, that's crazy. All right, people. So I've been troubleshooting this for a minute now, and I have no idea why it's not working in the browser. But if we use Burp Suite, it seems to be working. And apparently, I looked at some of the comments and the lab solutions on Portswigger, and they said that you have to try it a couple of times. But we don't have enough time to do that, right? So just keep trying it if you have the time. But this is how you would exploit this lab, and hopefully, after a couple of times, it actually works in the browser. But if we try it in Burp Suite, send the poison request, send a normal request to see if we get a 302. And if we follow the redirect, you can see that it is actually taking us to this domain, right? And there is the alert document.cookie. But if you try it in the browser, it's not going to work straight off the bat, I guess. But that is how you would solve this. And that is the end of the video. Web cache deception versus web cache poisoning. I hope this was fun. I hope this was informative. If you liked it, a like and a subscribe would be appreciated. Until the next one. Peace.